Section 4.6, partial fraction decomposition. Okay, so in this section we're going to talk about something that works against what we've been told all our lives. Okay, so let me explain what I mean by that. If you recall, if I gave you a problem like this, if I asked you simplify, you have 2 over x plus 1 minus 3 over let's make it a little bit more complicated. Let's say we have x minus 1 and x plus 2 over x minus 3. I asked you to simplify this. The first thing you would look at this problem and go, okay, I have two fractions, okay, and I'm subtracting them, so right away I need a common denominator. My common denominator in this case is x plus 1 times x minus 3, since the two denominators just have the highest power of 1. So I want to make both of these the same, so you multiply by x minus 3 on the top and the bottom for the first fraction, and then we get x minus 3. I'm going to put parentheses everywhere since we have two terms everywhere, and then we have x plus 2 over x minus 3, and we multiply by x plus 1 over x plus 1. So this is something we've been automatically doing. Anytime they ask us to simplify this, the denominators are the same now, so you can write them as 1. Okay, you can distribute on the top, so we get x squared minus x minus 3x plus 3, and out here we can distribute, but keep in mind there's a negative in the front, so we get x squared, but there's a negative, so it'll be minus x squared. We get x, there's a negative, so it'll be minus x. 2x, there's a negative, will be minus 2x. 2 times 1 is 2, there's a negative, will be minus 2. So these x's cancel. I can collect the x squares cancel, I can collect the x's. I have minus x minus 3x is minus 4x, minus 5x, 6x, 7x. Okay, so you get negative 7x, and then 3 minus 2 is 1 over this. I'm hoping by now in this class, this is something you can do. Given two fractions, we know how to add them up or subtract them in this case. So this is something we've been doing. This is something we've been trained. We do that with numbers too. For example, if they give us 2/5 minus 7/9, the first thing we do is find the common denominator and add them. We don't even have to think about it. We just do it. We react to it. What we want to do in this section is exactly the opposite. They've given us a rational. This is a rational expression. It's a rational expression because we have a polynomial on the top and a polynomial on the bottom. Okay, so when we have a rational expression like this, just one rational expression, what we want to do is figure out what two fractions did we add, or 3 or 4 fractions did we have to add to create this fraction, this rational expression. So we want to do the opposite this time. Okay, instead of going like this, like we just did, we actually want to go like this, and that is called partial fraction decomposition. We're going to take this fraction and break it down into smaller fractions, do the decomposition. Okay, so that's what we want to do. So I hope you understand our goal here. So let's see how we go about doing it. Okay, so let's say we're given this. So these are the steps for partial fraction decomposition. Okay, so let's say we're given a rational expression like this. We have something in the numerator and something in the denominator. Okay, we have a polynomial in the numerator, polynomial in the denominator. So the first thing we're going to do is this: if the degree of the numerator, okay, of this polynomial in the numerator is greater than or equal to the degree of the polynomial in the denominator, then perform long division. We did long division in the first section of this chapter, so that's what we want to do. Okay. Second thing, okay, we want to factor the denominator, factor d of x. So we want to factor the denominator. Now, depending upon the factors, we want to do one of these things. Okay, so let's take a look at that. If the factors of d of x are, remember our goal again, let me restate it. I want to take this fraction, they've given me this one fraction, and I want to break it up into smaller fractions. Okay, it might be two smaller fractions, 3, 4, it depends upon the fraction you're starting with. Okay, so keep that in mind. If the factors of d of x are a distinct, that means they're different. Like in this case, the factors of d of x are distinct, they're different. Okay, if the factors are distinct, okay, then we want to break it this way. So for example, we might have something on the top, n of x, and in the bottom we might have x minus a, x minus b, some two factors. Then this polynomial, this rational expression, not polynomial, this rational expression breaks to some constant capital A over the first factor plus some constant capital B over the second factor. So that's how we break it. So if you have a rational expression like this with two distinct factors, two different factors, then it'll eventually look like this: capital A over the first factor plus capital B over the second factor. Okay, now, and I'll give you examples of all of this when we do them in a minute. The second thing is if the factors are repeating. I do want to stress this, I'm just using two factors to give these examples, but you could have more. I could have x minus c here, then it would be plus c over x minus c. If I had x minus d there, then it would be plus d over x minus, and so on. So you can keep doing this process till you take care of every single factor. Okay, but if you can understand for 2, you can extend that to 3, 4, 5, and so on. Now if the factors are repeating, so in that case you have x minus a squared. So this is repeating because this is technically x minus a times x minus a. Okay, so in that case I want to break it down into a over x minus a plus b over x minus a squared. Okay, that's how they break to, because eventually we want to take this this rational expression and break it up into these polynomials, rational expressions. Keep saying polynomials, I mean rational expressions. Okay, now before I go any further, let me tell you why we are doing it this way. So our goal is to take a rational expression and break it up into smaller polynomials. So the thing is that once we find a and b, these capital A and B, we can add these guys up and get this back. Okay, so what is a common denominator here? X minus a times x minus b. It's exactly what I have here. Same thing over here. What is my common denominator here? Well, I only have one factor, which is x minus a, and the highest power of x minus a is what? 2. So my common denominator is this, which is exactly what I have here. Okay, now I cannot break this just into this because that basically gives me the same fraction back. That's why I need that first part. Okay, because the common denominators are still the same as what I have. Now I want to tell you, if this was a 4 here, let's say it was a 4, then I would have plus c over x minus a cubed plus d over x minus a to the 4th. So you keep, if they're repeating, you keep including till you get the highest power. You keep including the factor till you get the highest power. So once again, if you understand for 2, you should understand for 3 and 4 and 5. And then the last one is if the factors are quadratic. Quadratic means degree 2. So you could have something like this: x over ax squared plus bx plus c. So in that case the factor breaks to ax plus b over ax squared plus bx plus c. So in that case we break it down this way. Okay, now just to kind of show you what's happening, some mental checks you can perform. Okay, the degree, actually I'll write them down. Let me finish this, then I'll write all of that down. Okay, but out here you can see if the degree of the denominator is 1, the degree on the top is 1 less, so this is x to the 0, so we don't write this. Out here the degree of the denominator is 1, don't worry about the square, that just comes from the repeating. The degree of the numerator is 0, so we don't need to write those. Okay, and out here the degree of the denominator is 2, the degree of the numerator is 1. So the degree of the numerator is always 1 less than whatever the degree of the denominator is. So that's a mental check you can perform always. So now once we know how to break the polynomial, this is by far the most important step here, step 3. Because once you know how to break them, finding these constants that we have to, it's really easy. Okay, so let me show you that. Over here we have number 4, finding the constants. To find the constants, we do two things. Okay, we set factors to 0. And the second thing we do is we compare terms. And this will make sense once we take a look at an example. So those are the steps we have to perform to do partial fraction decomposition. It's a pretty cool process because you're actually doing the opposite of what we've been doing all our lives. So let's take a look at this example. Let's take this and see if we can break it up into what we had when we started up here. Okay, so actually let me start with something even easier to get you going. Okay, so let's say if I have 3x plus 1 over x squared minus 3x minus 10. So I want to do the partial fraction decomposition of this. Okay, so let's do that. So the first thing I need to do is, if you check, the degree on the top is 1 and the degree on the bottom is 2. If you recall, if the degree on the top was greater than or equal to the bottom, then we had to do long division, which we don't have to do. Then we have to factor the denominator. So let's factor the denominator. So in this case we get 3x plus 1 over x minus 5 and x plus 2. We know how to factor that. Okay, then what do? Then we take a look at if the factors of d of x are repeating, we want to break it down now. So now this thing, 3x plus 1 over x minus 5 and x plus 2 breaks down to, look at these two factors, they're distinct, they're different. So it'll break down into a over x minus 5 plus b over x plus 2. So that's what they're going to break down to. Okay, so now that we know what they're going to break down to, like I said, this is the most important step. Once you know this, finding a and b is not that difficult. So let's see how we find a and b. Okay, I want to solve for a and b. Anytime you're solving and you have fractions, what's our first step? What did we learn earlier? We want to get rid of the fractions. We want to multiply by the common denominator. Remember, if I were to add this, I should get this back. So the common denominator is whatever is here in the denominator. Okay, so keep that in mind, so you don't even have to calculate it. So I'm going to multiply everything by the common denominator, and this is probably the only time I'm going to do it, because it'll be really nice if you can do this in your head. Okay, so I get x minus 5 and x plus 2. I'll multiply this by the common denominator, and we get x minus 5 plus, we'll multiply the last term by the common denominator. And again, I do want to stress that this is the only time I'm going to do this, and that all the rest of the examples we'll just do it in our head, just easier than to write all of that. Out here this cancels, because this is over 1, we have multiplication, so we get 3x plus 1. Out here x minus 5's cancel, so we get a times x plus 2. Out here x plus 2's cancel, so we get plus b times x minus 5. Okay, so we got rid of our fractions. So now how do we find the constants? We set the factors to 0. So we take a look at each factor that we had and find out when it will be 0. When will this factor be 0? When x is 5. So we go x is equal to 5. So throughout this expression we're going to change x to 5. So we get 3 times 5 is 15. 15 plus 1 is 16. 5 plus 2 is 7. So we get 7a. We get 5 minus 5 is 0, so this term is gone. So we get this. So what does that tell me if I divide both sides by 7? A is equal to 16 over 7. Now we set the second factor to 0. This factor is 0 when x is negative 2. Again, we replace all the x's with negative 2. So 3 times negative 2 is negative 6 plus 1 is negative 5. We get negative 2 plus 2 is 0, so this term vanishes. Negative 2 minus 5 is minus 7b. So we get b is 5 over 7. If you divide by negative 7, the negatives will cancel. And that's it. We're done. So what did we get here? This tells me that this fraction that I started with, 3x plus 1 over x squared minus 3x minus 10, is the same as this fraction, because this is my decomposition. A over x minus 5. A is 16/7, so it's 16/7 over x minus 5 plus b, which is 5/7 over x plus 2. So there's your answer. Okay, let me just convince you for a second that that is the answer. So let's just go ahead and add this. So we're just going to check this. Okay, we're going to check to see if we get this back. So the common denominator is just x plus 2 and x minus 5. I'm going to multiply the top by x plus 2. So we get 6. I'm going to skip some steps. I'm just doing this fast just to show you. Plus 5 over 7 times x minus 5 divided by x minus 5 and x plus 2. You distribute here, so we get 16/7 x plus 32 over 7 plus 5/7 x minus 25 over 7 over the common denominator. Okay, I can add the x's, so I have 16/7 plus 5/7. The common denominator is 7, so we get 21 over 7, which is 3. So I get 3x. Then I add these guys, the numbers. I have 32/7 minus 25/7. So I get the common denominator is 7, so I get 7 over 7, which is 1. So I'll end up with plus 1 over, and you multiply the denominator, so we get x squared minus 3x minus 10. That's what we had. So you can see how this works. You might be wondering, why are we doing this? Well, there's actually a really nice reason for doing this. In other math classes, when we're given a problem like this, if you're trying to integrate it, or we're trying to do some type of transformation, Laplace transformation or something like that, it's a very difficult problem to do. But on the other hand, if we can change it to this problem where the fractions are smaller, it's a lot easier problem to do. Okay, so there's an advantage out here. We're taking a problem that's really difficult because it looks complicated with bigger exponents and things like that, and breaking it up into smaller fractions which are easier to integrate, or they're easier to find the inverse Laplace transforms. Okay, so there's a great advantage of using this method. Let me go ahead and give you another example. Okay, so let's say if I have 5x minus 3 over x cubed minus 3x squared. Okay, so let's do this. The degree on the top is 1, on the bottom is 3, so we don't need to do long division. All we need to do is factor the denominator, so that's easy to do. We can take out an x squared, so we get x minus 3, because there's an x squared common here, and that's it. Now we want to do the decomposition. This is the important step, actual breaking up. So let's take a look at it. Let me just first start by showing you what's going to happen. These two factors are distinct, they're not the same. So I'll start with this, a over x squared plus b over x minus 3. Correct? But wait a minute, this factor is repeating. What do you do when the factor is repeating? You start including it from the lowest power to the highest power. So if this is repeating twice, then we go x minus a, then x minus a squared, and so on. So in this case, I'm going to get rid of this and rewrite this. Okay, so this is repeating, so I'm going to go a over x plus b over x squared, plus I still have that other factor c times x minus 3. Okay, So if you think about it, because this factor was repeating, we need to include it twice from the smallest power to the highest, and the power start at 1. Okay, and then since this was distinct from this, we just include it once. Okay, now I forgot to mention earlier, I was telling you I was going to tell you one other thing you can check. There was two ways you can check to see if you're doing things right. One is, like I said, is to check the degree of the bottom versus top. If the degree of the bottom is 1, then the degree of the top is 1 less. Now out here you're looking at it and saying that's 2, but wait a minute, that's not the case. This factor is repeating. The degree of this factor is 1. It just repeats twice. It's x and x. Do you guys follow? So the degree is 1. So the degree on the top is also going to be 0, because it's going to be 1 less, so it's going to be 0. Okay, that's one way to check to see if you broke that down correctly. The other thing to do is, whatever the degree on the bottom is, that's how many constants you should eventually have to find. The degree on the bottom is 3, so I should need 3 constants. Okay, so now what do? We want to find a, b, and c. So the first thing we did, if you recall, is get rid of the fractions. Anytime you're solving with fractions, you always want to get rid of them, right? So you're going to multiply this by the common denominator, which will always be this. I already explained that to you, because eventually when you add this, you should get this back. So that is my common denominator. So if you multiply this by exactly the same thing, that will cancel. So you just get 5x minus 3. If I multiply a over x by this, my common denominator, the one of the x's will cancel. Then you'll be left with ax times x minus 3. If I multiply this b over x squared by b over x squared by my common denominator, this will cancel. So you're just left with b times x minus 3. Plus, if you multiply this by your common denominator, which is this, the x minus 3's will cancel, so you're left with just c times x minus 3. So you can do this in your head. It's much better than trying to write it all out if you follow it. If you don't, you can multiply each term by the common denominator and do it. Okay? Alright. Now that we did that, we got rid of our fractions. How do we find the constants? What did I say to do? Set factors to 0. So let's do that. I have factors here. I technically only have 2 factors. This happens to repeat. So let's set each one to 0. When will this be 0? When x is 0. So if you set x to 0, 5 times 0 is 0, minus 3 is negative 3. 8 times 0 is 0, so this term's gone. 0 minus 3 is negative 3, so you get minus 3b. Okay, and this, by the way, I'm sorry, the x minus 3's will cancel, so you should get just cx squared. Okay, because when you multiply this by the common denominator, this will cancel, so you just get cx squared. You multiply by that. C times 0 is 0, so if you divide both sides by negative 3, you get b is equal to 1. So we got that. Now I want to set this factor to 0 when x is 3, because you have x minus 3, so it will be x is 3. So now let's see what happens. You get 5 times 3 is 15. 15 minus 3 is 12. You get 3 minus 3 is 0, so this whole thing is gone. 3 minus 3 is 0, that whole thing is gone. So you get 3 squared, c times 3 squared. 3 is squared is 9, so you get 9c. You divide both sides by 9. So we get c is equal to 12 over 9, which we can reduce to 4/3. Okay. There's no more factors to set to 0 now. So what do? How do I find a? Because I'm still missing a. Well, that's why we compare terms. Okay. Now let me show you, talk about that for a second before I do. If I have 2 polynomials, let's say I have ax squared plus bx is equal to 5x squared minus 3x. If I have 2 polynomials equal, the only way they're going to be equal is if the coefficients of the variables are the same. Variable terms that are the same are the same. So I have x squared here, I have x squared here. So that tells me I have 5x squared, ax squared. So a must be 5. Over here I have bx and negative 3x. So I compare the x terms, so b must be negative 3. So anytime you have 2 polynomials equal, the only way they're going to be equal is if the coefficients of the terms are the same. And when I say of the terms, I mean of the x squared terms are the same, of the x terms are the same, and so on. Okay. So coefficients of the like terms are the same, basically is what I meant. So now what term do I compare? Well, if you think about it, if I were to multiply this, I would get what? Ax squared minus 3ax, correct? That's what I would get. So I can compare the x squared term, okay, because a is a coefficient of the x squared term. So I'm going to compare the x squared terms on both sides. Do I have an x squared term on the left? No, so I get 0. How about on the right? I have ax squared, so I have a. That is my coefficient. Remember what I just said a minute ago, you're comparing the coefficients of the like terms. Okay, out here there's, if you were to distribute the b, would you get a bx squared at all? No. But I have a cx squared, so this coefficient, so this is what we have. Let me go back to, if I have ax squared plus cx squared is equal to, let's say, 5x squared. So since these two polynomials are the same on either side, that tells me what? The coefficients on the left hand side should equal to the coefficients on the right, so a plus c should equal to 5, because this coefficient plus this coefficient should equal to this one, and that's what we just did. Okay, so that tells me a is what? A is equal to negative c, and I know c from up here, which is what? Minus 4/3. So now I know a. So we are done. So what does this fraction break to? Okay, it breaks to this. This original problem that we had breaks to this. All I have to do is replace a, b, and c. So I get minus 4/3 over x plus 1 over x squared plus 4/3 over x minus 3. If I were to add these three fractions, I would end up with what I started with up here, this thing. So you can see we did a decomposition here. Okay, we broke it into smaller fractions. Also, we compared terms. Let's take a look at two more examples. Let's do one where you have to do, let's do one with a quadratic factor. So let's say if I have 4x squared minus 3x plus 2 on the top, and on the bottom I have x cubed minus x squared x. Let's do that. So the degree of the top is 2 and the bottom is 3, so I don't need to do long division. The last problem I will do will involve that. But I can factor the denominator. I can take an x out, so I get x squared minus 1, but I know how to break that too, right? You can do it on the side. It's difference of two squares, because you can write 1 as a square. So I can break it down into, actually let's make it plus. So let's do x squared plus 1. Okay, so we broke our polynomial down. I mean factored a polynomial. Now let's break the fraction. Okay. Now, these two factors are different, so we would write it as a over x plus b over x squared plus 1. None of them are repeating, but this fraction is quadratic. You can see it's degree 2, so on the top we should have degree 1, so this should be bx plus c. I hope you realize that. Okay, so that's what we did. So the next thing we have to do is find the constants, and again, if you want to check the degree of the denominator is 3, I should have 3 constants. The degree on the bottom is 1 here, on the top it's 0, on the bottom it's 2 here, on the top it's 1. So we know we did everything correctly. So we multiply everything by the common denominator to get rid of the fractions, so we can find a, b, and c. On the left we get 4x squared minus 3x plus 2. On the right we get, if you multiply this fraction by this, the x's will cancel, so you get a times x squared plus 1, plus when you multiply this fraction by this, the x squared plus 1's will cancel, so you'll get bx plus c times x. Okay, now that we did that, let's set factors to 0. So the first thing we want to do is, this factor is 0 when x is 0. So on the left, what do we get? 4 times 0 is 0, minus 3 times 0 is 0. We just get 2. We get 0 plus 1 is 1, so we get a. This whole thing times 0 is just 0. So a is 2, so we know that. The next thing we want to do is set this factor to 0. But that cannot happen because x squared plus 1 is never 0. Anytime you square something and add a 1, you get a positive number. So we can't do that. So then we're going to have to compare terms. Okay. Now, whenever you're comparing terms, it's always a good idea to write down what you're going to look for. We're looking for b and c. So if I were to distribute this, I get what? Bx squared plus cx, right? So I'm going to compare the x squared term. What is my x squared term on the left? I have an x squared term, so it's 4, the coefficient. We're looking for the coefficients when we compare terms. Out here, if you were to distribute this, you would get ax squared plus a. So my x squared term is what? A. Out here, my x squared term is b. Since I know a is 2, what is b then? b is 4 minus a, which will give you 4 minus 2, which is 2. So now you know b. Okay. Now, how do I find c? C is associated with x, so let's compare the x term. What's the coefficient of the x term on the left? Negative 3. This is my x term, this is my coefficient. Do I have an x term here? I have ax squared plus a. There's no x term here, so that's not a big deal. Is equal to c, because I do have an x term there. Okay, so there we go. I found a, b, and c. So let's write down a fraction. So according to our breakup, it breaks into this: a over x. Okay, a is 2, so I get 2 over x, plus b, which is 2x, plus c, which is minus 3, over x squared plus 1. So that's what that fraction breaks to. This original fraction that we started with, this fraction, breaks to this. If you were to add these guys up, you would end up with that original fraction. Okay, so that's how we do that decomposition. Let's take a look at one where we do have to do long division, so you guys can get used to that. Okay, so let's say if I have 12x squared cubed, let's do, minus 4x squared minus 1 divided by, I have x cubed minus 4x. Okay, so let's do this. So the first thing we're going to recognize is the degree on the top, okay, is greater than the degree on the bottom. Let me do this. Let's make this more interesting. Let's go x squared minus 4x plus 4. The degree on the top is greater than the degree on the bottom. So the first thing we're going to have to do is long division. So let's do that. On the top there are some terms missing. One term missing actually. So let's put a placeholder. And we're going to divide by this. Okay. X squared goes into 12x cubed 12x times. So you get 12x cubed minus 48x squared plus 48x. Subtract, this becomes negative, positive, negative, this cancels. So you get 44x squared minus 48x minus 1. Then x squared goes into that plus 44 times. So we get 44x squared minus, we get 176x plus 176. You subtract the two. This becomes negative, positive, negative. This cancels. Okay. So I end up with so we get 136 minus 8 is 128. So we get 128x plus minus 177. Okay. So there's nothing I can multiply this divisor by to get 128x. I'm done. So this problem now can be written as this. This problem on the top can be written as this. Remember, we write our answer as a quotient plus the remainder over the divisor. So my quotient is 12x plus 44 plus my remainder, which is 128x minus 177 divided by my divisor, which is x squared minus 4x plus 4. So we started the decomposition. We took this and broke it down into this. Now we want to do the decomposition just for this, because this is just part of the answer. So whatever we get from doing the decomposition, we'll plug it in here and add it to this. Okay, so let's just do that on the side. So let's just concentrate on that. 128x minus 177, and the denominator can be factored into x minus 2 x times x minus 2, so I can write it as a square. So since the factors are repeating, you have x minus 2 times x minus 2. I'll break it into a over x minus 2 plus b over x minus 2 the whole squared. We talked about repeating factors. That's how we break them. Then we multiply by the common denominator, so we get 128x minus 177 is equal to a times x minus 2. When I multiply this guy by this, one of the x minus 2's cancel. When I multiply this by this, the x minus 2 squares cancel, so you just get b. Alright, we want to find a and b, so let's do that. We set factors to 0, so if we set x to 2, we get 128 times 2 is 256. Okay, so we have 256 minus 177, so we get 9, and this is a 4, so carry 1, so 79. So we get negative 79 is equal to 2 times 2 minus 2 is 0, so we just get b. So b is negative 79. There's no other factors to set to 0. There was really only one factor repeated. So we want to compare terms. So let's compare. What are we looking for? A. If I distribute this, I get what? ax minus 2a. So I'm going to compare the x term because a is associated with x. Okay. You can also compare the, let's do the constant term. Let's try do that. So I'm going to compare the constant term, the term that doesn't have a variable on the left, which is minus 177, and on the right I'll compare the constant term, anything that doesn't have an x in it, so it's negative 2a plus b. This doesn't have an x in it. I do know b is 79, so I get 177 is equal to negative 2a minus 79. Okay, so you move the 79 over, so I get 177 plus 79 is equal to negative 2a. So you get negative 2a is equal to 98. I'm sorry, negative 98. Okay. So we get a divided by 2 is equal to, the negatives will cancel, 49. Okay, so that's what we got. So my fraction breaks to, so my original answer is what? Remember, my answer is this. I do want to stress this. It's really this, where this breaks to this. So it'll be 12x plus 44. So the answer is 12x plus 44 plus, I get this fraction. We just found the decomposition for this to be this, a over x minus 2. A is 49, so it'll be 49 over x minus 2 plus b. So b is, so we get plus negative 79. B is negative 79 over x minus 2 squared. So if you were to add these fractions up, you should get that original fraction back. And that's how you do partial fraction decomposition. Just take a look at some examples in the notes and make sure that you follow them. The key step is the breaking up of the partial fraction. How do you break this up? Because if you cannot break this up, I'm sorry, not that, this. If you cannot break this up, then it doesn't matter whether you can find a or b. If you struggle with that, if you know, that's not important. Finding a and b hopefully is not too bad. You just set factors to 0 and compare terms. And in this case we compared the constant terms.